Okay, let's look at the homework 3.6, 3.7, number 14. All right, so we're going to try to find the relative max and the relative min on this one too. All right, so first we're going to rewrite it. This is going to be equal to x times quantity 4 minus x squared raised to the 1/2 power, because square root is equivalent to 1/2 power. All right, so let's take the derivative. So y prime is equal to, all right, so we're going to have to use a product rule. So this is the first guy. This is our second guy, right? Derivative of the first guy is 1 times the second. So quantity 4 minus x squared raised to the 1/2 power, right? Plus x times derivative of the second. So put 1/2 in front. Keep the same quantity, 4 minus x squared. Subtract 1 from the power, so negative 1/2 power. Then multiply by derivative inside, which is negative 2x. Right? So there's 2 on the bottom and 2 on top. Cancel those out. All right, then try to simplify as much as possible. So this guy is, this is just a square root of 4 minus x squared. Right here, you're going to have a negative sign here, so it's going to be minus. Right, there's x here, and also another x still here, so that's x squared. And over, because this is a negative power, we know that 4 minus x squared is on the bottom. Then you have still 1/2 power, which is square root. All right. Then we can combine them together by taking the common denominator, which is going to be square root of 4 minus x squared. Right? So if you take the multiply top and bottom by square root of 4 minus x squared, so it's going to be square root of 4 minus x squared times square root of 4 minus x squared, which is going to be 4 minus x squared. Then you have minus x squared. Right? So this is going to be 4 minus 2x squared over square root of 4 minus x squared. You can factor out 2. Then you have a 2 minus x squared over square root of 4 minus x squared. All right, so we can set that equal to 0 to find the critical number. All right, so it's going to be a 2 minus x squared must be 0. Right, so that's the numerator, and you don't have to worry about 2. And then you can add x squared to get the 2 has to be equal to x squared. Right? Then we can just take the square root. So it's going to be plus or minus square root of 2 is the critical number. So these are the critical numbers. All right. So those are the critical numbers, and so we're going to do a number line again to see if we get a local max or local min. Right, so this is going to be square root of a negative square root of 2 and positive square root of 2. Right, So you could try something like x equals negative square root of 3, or something like that. And then we just need to know if it's positive or negative. So here, so bottom is going to be always positive, so we don't have to worry about that, right? So you put the negative square root of 3, so it's going to be 2 minus 3, so that's going to be negative. So you have a negative here, right? Then here, you're going to have, let's see, so it's actually, the domain is between negative 2 and a positive 2. Right? Then between negative square root of 2 and a positive square root 2, we can try 0. Right? If you put 0 here, so you have positive. Bottom is always positive, so it's positive here. We're looking at the y prime. Right? And between square root of 2 and 2, so square root of 3. Right? 2 minus 3 is negative. And bottom is positive, so it's going to be negative. So you can see that the y is decreasing before square root of 2, increasing between negative square root of 2 and positive square root of 2, and a decreasing, right? So you're going to have a minimum at negative square root of 2, and local max at positive square root of 2, right? So let's find those values. So y at the negative square root of 2 would be, right, you have x, so it's a negative square root of 2, square root of 4 minus, right, negative 2 square root of 2 square would be just 2. So it's going to be negative square root of 2 times square root of 2, which is negative 2. And y at the square root of 2 would be positive square root of 2, square root of 4 minus 2, which is square root of 2 times square root of 2, which is positive 2. All right, so we found a minimum here. Local minimum is negative 2, and local maximum is positive 2. So let's type that in. Right, so relative maximum is at square root of 2, comma, 2. Local min is negative square root of 2 times negative 2. Right, so let's see if this is correct. Okay, it came back. We got the relative max and the relative min correctly. Right, that's it. I hope that this was clear.